and velocity. Speed is also a very common term that we use in everyday life. Speed tells us how fast we move. Suppose you go for a morning walk with your father and both of you cover a distance of 1 kilometer. You cover it in 5 minutes and your father covers it in 10 minutes. Then what is the speed? If we calculate the speed of, so one is, you can find out 1 kilometer per 5 minutes. Other one, 1 kilometer per 10 minutes. So we will divide distance by time to find out this is speed. So speed is distance covered upon time. So we will measure it in kilometer per hour or meter per second or any unit basically. Here we need a unit of distance and in the denominator we need a unit of time. This is the unit that we shall be using in SI system, meter per second. See, now again take the same example. You ran for 5 minutes. Your father ran for 10 minutes. But it doesn't mean that throughout the 5 minutes you were having the same speed. Maybe at some point of time you were running very fast and at another point of time you were actually walking. So the speed was not same. So this is speed, when we calculate the total distance covered by you divided by total time, will not tell anything about your speed at any particular point of time. So accordingly, we define two types of speed. Instantaneous speed and average speed. Instantaneous speed is the speed of any body at particular point of time. Distance upon time at one particular point of time. The speedometer of the car that tells us about the instantaneous speed. It tells about the speed with which the car is running at that particular moment when you are looking at it. Average speed tells us about the total distance covered in a given time. So what we talked about, the total distance was 1 kilometer and time was 10 minutes or 5 minutes, that was actually average speed. Take another example. Suppose your school is 5 kilometers from home, you go by car or on foot. How do you calculate the speed? You just see what is the total distance, 5 kilometers, and divide it by the time that you take. Suppose you take 1 hour walking, and then what will be the average speed? 5 kilometer divided by 1 hour. So 5 kilometer per hour. This is the average speed. But again, it doesn't mean that throughout the 1 hour you were moving with the same speed. Your speed keeps on changing. So that is the average speed. Instantaneous speed you will do in detail in higher classes. How do we calculate this instantaneous speed? Here we will do average speed. So average speed is total distance divided by total time taken to cover this distance, irrespective of the variations. Suppose you cover a distance of 1 kilometer with a speed of 20 km per hour, another 1 kilometer with 30 km per hour, and then another 1 kilometer with 50 kilometers per hour. You will take just the total distance, 1 plus 1 plus 1, and same way you will take the total time taken to cover these distances. This will give you the average speed, unit meter per second. Now, another thing. This speed simply, it is the rate of change of distance, how the distance is changing with time, how fast you are moving. Suppose we also want to know in what direction you are moving. You are moving towards right or left, towards north or south, then this quantity is not sufficient. This is telling us about the total distance covered per unit time. If you keep on moving around a path, then it is simply giving you how much distance you have covered and how much is the time taken. Distance divided by time, that is the average speed. If you want to know the direction, then we take another quantity, that is called velocity. And this is displacement upon time. Displacement tells us distance covered in one specific direction. So velocity will also give us direction. So it tells us how fast an object is moving and in what direction it is moving. And again, just like the speed, we can have velocity as average velocity and then instantaneous velocity. Average velocity is total displacement upon total time, and instantaneous velocity is velocity at one particular instant of time. So average velocity is total displacement upon total time. So it means if the displacement is 0, then the average velocity will be 0. So again, taking the same example which I took when we were talking about the displacement, if I take a body starts from A and then returns to A, the average speed will be 2 pi r divided by time taken, and average velocity will be 0. So average velocity means total displacement upon total time. It tells us basically in what specific direction the body is moving and with what speed. Suppose I say a body starts from A, it goes to B and then it goes to C. A to B it takes time t1, B to C it takes time t2. Then velocity in this part we will take just AB by t1. Velocity in this part we will take BT. But if I have to calculate the average speed, I can simply add AB plus BC divided by t1 plus t2, but this will not be with velocity. We need the displacement then. This is the velocity along this direction. This is the velocity along this direction. The velocity has changed even if the body is moving with constant speed. So if a body is moving like this and then suddenly it changes its direction like this, so its direction of motion has changed. It means the velocity has changed, because velocity includes two concepts in it: speed and direction. Change either in speed or in direction means a change in velocity. So this is the velocity in this direction. If I again use east, west, north, south, this is the velocity of the object towards east, this is the velocity towards north. And if I want to calculate the average velocity, I need this. So average velocity will be AC divided by T1 plus T2. taking again the same example. The body takes time t1 to move from A to B and t2 to this. So average speed is AB plus BC upon t1 plus t2. Average velocity is AC upon t1 plus t2. See the difference. Average speed, I have to take total distances. All distances are to be added. This will give me the total distance, AB plus BC plus CD plus whatever, divided by total time. But average velocity, I have to see the distance of the final position from the initial position, straight line distance. That is the displacement divided by the time. Okay, if I take AB, BC, and then it comes back in a time say t3, then average speed will be AB plus BC plus CA, and here it is. What about average velocity? Average velocity will be 0 because the displacement of the body is 0. I am throwing one particular object in upward direction. It moves up to the highest point and then it returns. When it is moving up, the velocity can be taken say positive. When it is coming down, its sign is reversed. Now it is minus. But speed is same. Whether it is moving up or down, speed simply gives us distance per unit time. While velocity is telling us also in what direction the body is moving. Whenever direction is reversed, we have to reverse the sign. And magnitude, even if it is same, the velocity is changing. Take one more example. Suppose a body is moving on circular path with a constant speed of 20 km per hour. A body is moving on a circular path with a speed of 20 km per hour. It is not changing. So we say that the speed is constant. What about the velocity? Is velocity also constant? The answer will be no. Even if the body is moving with a speed of 20 km per hour, the direction is not fixed. If it is moving like this, at this point, it is moving like this. At this point, it is heading towards this. Here, it is this. Here, it is this. At any point, to find out the direction in which the body is moving, we just draw a tangent. Tangent tells us that it is heading in this particular direction. So we say that even if the speed is constant, the direction of motion is changing continuously. And change in direction of motion means the velocity is changing. Now with it we come to another concept. If the velocity is changing, what does it mean? Or if the speed is changing, then what does it mean? Speed means, say, okay, let's consider that you are sitting in a car. At any moment, the speed is 10 km per hour. After 10 seconds, it is 20 km per hour. Then after 10 seconds, it is 30. Then after 10 more seconds, it is 40. So for every 10 seconds increase, the speed is also increasing by 10. So it means the speed is not constant. It is changing. Here, the speed is changing at a constant rate. we call this uniformly accelerated motion. And there is another term now, acceleration. Acceleration means the change in speed or even the direction in which the body is moving. So I can say the change in velocity. Change in velocity means the motion is accelerated motion. So acceleration can be defined as change in velocity upon time. What will be the unit? Meter per second upon second. That's why I said it is the speed of speed. If the speed of any body is constant, the acceleration is zero. If the speed is changing, then the motion is accelerated. If the speed is changing at a constant rate, the acceleration is constant. Just like this. If the speed is changing but not constantly, say it is 10 here, it is 40, then it is 80, then it is 120, then the increase is not proportional. So we say it is non-uniformly accelerated body. Here it is uniformly accelerated. So this unit will become meter per second square. I gave you examples for accelerated motion. One is this one. Another you may see, suppose I drop an object from certain height. From first floor I drop a ball and you are looking at it. Now when you have dropped it, drop means its initial speed is 0. After 1 second, at t is equal to 0, its speed is 0. After 1 second, its speed becomes 9.8 meter per second. After 2 seconds, it becomes 19.6 meter per second, and so on. For every second, the increase is 9.8 meter per second. We call it gravitational acceleration actually. This acceleration, the increase in speed is coming because Earth is pulling the object towards itself. Earth is pulling, that's why speed is increasing. So when we drop an object, this is the acceleration. The object does not come down with constant speed. Its speed increases continuously, and for every second the increase is 9.8. Okay, take another example. Suppose an object is moving on a circular path and the speed is 20 km per hour. This is the speed of the object on circular path. Now my question is, if the speed is constant, is the motion accelerated? The answer will be yes, because acceleration means speed and also direction. Acceleration means velocity actually. So here velocity is changing when the body is moving on circular path. There is an increase, there is a change in the direction of motion. So there is a change in velocity, and hence the motion is accelerated motion. So for a body moving on circular path, the velocity changes, or we can say the motion of an object on circular path is accelerated motion. Okay, it is denoted by A, or I can write it V2 minus V1 upon T2 minus T1. This I can write in the form of expression, change in velocity upon time. Speed is distance upon time. Velocity is also displacement upon time. So giving you the expressions for all these. Okay. Speed, average speed. Total distance upon total time. Average velocity, displacement upon time. Acceleration is rate of change of velocity. Change in velocity divided by